Hey YouTubers, it's Tom here.
And Eric.
And we're here to teach you about Koch's Snowflake.
So Tom, what exactly is Koch's Snowflake?
What a great question, Eric. Koch's Snowflake is actually just a mathematical curve.
But is it a fractal curve?
In fact, it is, one of the earliest. Alright, now we're going to look at trying to construct Koch's Snowflake. It might seem like a fairly difficult task at first if you were just to be like, oh, try to construct this, but it's really easy and we're going to do it step by step. So first you're going to want to start off with one single line segment and label your endpoints A and B. Now from there you're going to select A and B and go to the transform menu and then dilate to a 1/3 ratio, then repeat this process and dilate it to a 2/3 ratio. This will give you an idea of what to do next. Now select your innermost point that you made as a mirror. Now select your other point that you constructed and rotate it 60 degrees. This will give you your new point to which you are going to construct your first part of the triangle. Alright, now you can hide your initial line segment because it's not needed for this process any longer. Also, we want you to connect from point A to point B, the dots, in order. Now this gives you the first part where you're getting ready for your iteration. Now select points A and B and then go to the transform menu and now go down to iterate. From there you're going to select point A and then the next one over and then go down to structure and add new map. Now select that point and the uppermost point and continue doing this until you get to point B. Now when you get to point B, you are finished with the iteration and you can get ready for the next step. Alright, so now you finished your iteration and what you're going to do now is select your 4 main segments, and we're just going to hide them because it'll make our snowflake look prettier, so we're just going to Control H having selected those and get rid of them. Now we are going to mark point A as a mirror and select point B, and we're going to transform and rotate it 300 degrees. This will bring us to where we have an equilateral triangle if we were to connect all of those dots with straight lines. Now to create a custom tool of your snowflake, you're going to select the whole snowflake that you've constructed thus far and go to Custom Tool, Create New Tool. I'm going to label mine Snowflake Koch just because I can realize what it is from there. Now you go from point B down to the point you have rotated, and then from that point up to point A, and it completes your snowflake.
Let's take a look at the perimeter of Koch's Snowflake. First, you have a segment of length 1. Now, if you change it, you can take it and divide it into 4 segments of length 1/3. If you divide it again, you can get 16 segments of length 1/9. Now, if you divide it one more time, you can see that you can find 64 segments of length 1/27. As you can see, at every step there are 4 to the nth segments of length 1/3 to the nth, meaning the total perimeter is 4/3 for this part of the snowflake. Since there are 3 parts of the total snowflake, we must multiply our perimeter by 3, giving us 3 times 4/3 to the nth power. Now by taking the limit of our perimeter from n to infinity, it equals infinity, thus giving us an infinitely long fence.
Now as Eric has showed you that there's an infinitely long fence, now let's take a look at the area of Koch's snowflake. So now let's take a deeper look into the area of Koch's snowflake. If we were to take an equilateral triangle and observe the side length S, we can determine from this following picture that the area of this triangle is going to be the square root of 3/4 times S squared. Now let's look at the first iteration of this. When you look at the first iteration, the iterations themselves lengths are S/3, and there are 3 of them, so you're going to multiply this times 3 and the initial area and add those 2 together. Continue this process for the second iteration and the third iteration. Soon you will come to realize that there is actually a pattern. Now in this pattern, you can see that at the kth iteration, we add 3 times 4 to the k minus 1 power additional triangles of the area square root of 3 over 4 times s over 3 to the k squared. Now this adds up to square root of 3 over 4 s squared times 1 plus the sum of all numbers is k equals 1 to n of 3 times 4 to the k minus 1 over 9 to the k. Now notice the sum inside the parentheses is the partial sum of the geometric series with ratio r equals 4/9. Therefore the sum converges as n goes to infinity, so we can finally obtain the area of Koch's snowflake. Now notice that this number is actually a finite number opposite of the perimeter, which was an infinite number. This is Koch's snowflake. So as you can see, it is possible to have an infinitely long fence bounded by a finite area.
And that's the way the snowflake falls.
So until next time, I'm Tom.
And I'm Eric.
And we're out of here.